Good morning. I'm going to go through our example problems. So if you missed class, you need to see the example problem again, anything like that, you'll have it. So we are going to do just a basic kinematics problem. There are two parts to this problem, so you get to see me use two different equations, and you see the process twice, which is good. Let's go ahead and get started. So it says that Miss Nichols is skating radical down the street if she starts at rest and travels for 35 seconds and has an acceleration of 0.5 meters per second, which is the same thing as meters per second squared. What will her final velocity be and what will her final position be? So those are the two different parts of the problem. Whenever I do a problem, I always start off with writing the values for what I already know with their symbols, right? So it says right here that it starts at rest. So that to me means that V naught, my initial velocity, is 0 meters per second. Okay, it also gives me a time at 35 seconds. That's a T, I promise. It also gives me an acceleration value, which is 0.5 meters per second squared. What we're looking for is our final position and our final velocity. Okay, so let's do the position one first. We need to pick an equation. That's our first step. If I go back, let's turn, oh, that's inconvenient. If I go back a couple of slides, you'll see I have my equations and when to use them. So we have time values, we have acceleration values, we have an initial velocity, but we don't have a final velocity value. So it says right here, you don't have final velocity, use this one. So we're going to use this equation right here. So I'm going to go back. And I'm going to rewrite everything real fast. 0 meters per second, acceleration is 0.5 meters per second. And our position is what? So we're going to use the x equals x naught plus v naught t plus 1/2 at squared. All right, so let's plug in our zeros. That's our next step. So I'm going to go ahead and say my initial position is 0. I don't have any reason to believe otherwise, so I'm going to go ahead and do that. We also know that our initial velocity is 0, so I can cross this out because 0 times anything is still 0. So 0 times time, it's 0. So that's going to mean I can rewrite my equation as x equals 1/2 at squared. I've got values for all these things. Let's plug them in. So 1/2 times 1/2, 0.5, times 35 seconds squared. If I plug this into the calculator and I plug it in just like this, I'm going to get a value of 306.25 meters. Okay, and that's it. That's my final answer. I tend to leave my numbers in the hundredths or thousands place. It just kind of depends. We're not very particular about significant figures in physics classes. I don't know. It's just one of those things. But that's only 1/2 the problem. We still need to do final velocity. All right, so let's go back and let's pick. I'm going to leave all the annotations. We'll just have to read through them. Nope, it won't do that. Oh well. So we, based off of our initial stuff in our problem, we don't have position information. So right here it says I don't have position. So I'm going to use this equation. You could, since we have position information from solving it, use this first equation up here, and that would be fine. But I'm just going to go ahead and assume that you're solving these parts in two different scenarios, and that way you don't have to use information from one to solve the other. Let's go back to the problem. Oh, it's still there. And I want to erase all my old work. It's like it never happened. And now we're going to solve for velocity. So just give me a minute to erase. Screencastify is very slow for annotations, but we love it anyway. Okay, get my pen. I've already picked my formula, and that was going to be my velocity final equals velocity initial plus AT. I'm looking for my velocity final. I already know from the problem initial velocity is 0. I can plug that in as a 0. Wow, it goes away, it cancels. And now I'm going to be left with rewriting my equation. Velocity final is acceleration times time. I can just plug in my values. I know both of them. So acceleration is 0.5. And then the time is 35 seconds. Remember, your time always has to be in seconds. It can't be in minutes or hours or anything. If you're going to calculate anything, get your units to work. It has to be in seconds. That means my final velocity is going to be 17.5 meters per second. And that's it. So you read your problem, you figure out what you already know, write down what you don't know. Oh, I didn't know position. Go pick your equation, plug in your zeros, solve algebraically. We really didn't have to this time. And then plug in your values from your problem and you get an answer. Magic. All right. That's it. Hopefully this has been helpful. Y'all have a good day.